Hey everyone, it's John, and today what we're going to be doing is doing some more network automation, this time again with Nornir, but this time it's going to be really quite a short video today. So the gist of it is yesterday on Twitter I posted a picture of this topology and described how I used Nornir to automate a full OSPF BGP deployment. You'll remember this pretty much from my last video. It's the same script effectively with a slight modification. The difference here is in scale, which somehow garnered a bit of interest, and I had a few messages asking me to actually record a video of this script deploying. So that's what we're going to do today, is effectively deploy BGP, have a full iBGP mesh which results in 1255 peers or peerings, and then we'll do some testing to make sure it all works. Okie doke, so that's the plan for the video. With that said, let's kick on, let's do it. Okay, now normally you would see me go through the script in quite a bit of detail as to what part does which, but this script really is just a repeat of the last one with a very slight modification. The last one being the deploying iBGP OSPF via Nornir. So if you want to see more information about the script, then go back to the previous video before this one I did on Nornir and watch that, because otherwise me going through the whole thing again, it's just going to be both repetitive and extraneous. So I'm just going to leave the choice to you. If you want to see more detail about how the script works, watch the previous video and I'll just quickly cover over the actual changes. Like the last one though, remember, is that if you're using Cisco viral images, the actual OSPF commands on this won't take. I'm using Cisco IOU, and if you're using Real Gear, it depends on the image which you have, okay, because we're going to be using IP unnumbered on the loopbacks, IP unnumbered on the interfaces to borrow the loopback addresses to actually get this OSPF underlay, okay? So with that said, let's go and look at the actual script and see the differences. So if I just go over here and look at the script, okay, so the only real difference is this part here, okay, and I'll show you what this means in a wee second. And I've extended the range because we're doing 50 routers this time, so the actual ranges went up to 51 to encompass all 50. Now what this part is doing is we've created a variable called IPvZero. I wasn't very creative, so I just used my username, okay? So all this is doing is taking the value of the IP address of each host as we iterate through them all. Now that's obviously going to be changing, and what I want to do is actually parse out the last two characters of that string, okay, and assign it to the variable num. Then I'm going to be using that for loopback. So effectively it looks like this. When we do, if the IP address is 192.168.31.143, we're actually just parsing out the last two, which gives us 43 here, okay? And if you notice, if it's 103, it's going to be 03, but remember Cisco iOS is going to effectively ignore the 0, so we actually get a 3 character, so it's a really easy way to get that kind of functionality which you're after. So again, try 149, we'd parse out the 4 and the 9, there we go, simple as that, that's all that's doing, and like I say, the range is actually changing, okay, so that's really just it. So with that said, how about we go and deploy the script. Now before I do that, what I will do is just quickly show you the configurations. Now we've got out-of-band management configured on it, but that is it. No actual production configuration has been done on it, i.e. no OSPF, no actual IP addresses on the links connecting the routers, only just your management. So if I do a show run, that is it really, okay. So what you see here is we've got a VRF here with an IP address and SSH configured on it. That is all we've got, SSH, and that's it. And that's true of all the routers. Just grab another random one. Okay, same again. So let's go and deploy the script then and just see what happens then. So pull this up here and just clear you. And all we'll do is just do Python 3 underlay. Now this will take a minute or two to do, so I'll just pause the video and come back in 2 minutes. And now Nornir is just blasting through all this configurations, creating the OSPF underlay, creating the full iBGP mesh of 1255 peers, and that's pretty much it. It's just going to get to the very end and we'll check out the actual results. Just going right through it all. This part's the funnest part, just seeing an absolute deluge of config flying through your screen. It feels like you've got superpowers. Almost done. There we go, that's us fully configured. If we just scroll up, you'll see all the configurations it's done. It's put an absolute massive amount of configurations on. So if we actually go to a router now, and we did like say a show IPBGP sum, we'll see all the peers we've got here, and if we do a show IP route, we're going to have our OSPF underlay configured. But let's go and maybe put a router on. We'll get router 37. If we do int loop 37 into IP address 37, no, 37, and just make it a /32, whatever. Okay. And do router BGP 65001 net, and put the mask on. So we're actually advertising that into BGP. Okay, so that's advertised. So let's grab a router, I don't know, maybe router 9 over here. See if it now sees it. Yep, so show IP route. And there's our BGP route down there, and if we can ping it, 37, 37, 30, oh. There we are, if we trace to it. There we go. So that's us, that's the full BGP topology deployed, as well as OSPF, pretty much from scratch, with some SSH connection and out of band management, but the rest was all deployed with Nornir in about, what, 2 minutes time, and that is for 1,255 peerings. Okay doke. So with that said, I'll put this code on my GitHub if you want to try it, and that's pretty much the end of the video, so thanks very much, and I'll see you guys soon.